Hello everyone, this is Aju SR. I am currently pursuing Achieving Test College of Engineering, Bangalore. I am presenting a presentation about problems on Thevenin secret circuit and superposition theorem. Definition of the Thevenin secret circuit. The equivalent circuit is a voltage source with voltage in series with resistance. The Thevenin equivalent voltage V is open circuit voltage at the output terminals of the original circuit. Ex- Example of the Thevenin equivalent circuit. The Wheatstone bridge in the circuit shown in the figure 1 is balanced when R2 is equals to 1200 ohm. If the galvanometer has a resistance of 30 ohm, how much current will be directed by it when the bridge is unbalanced by setting R2 is equals to 1004 ohm. Let's let's move to the superposition theorem. Superposition theorem states that in any linear bilateral network where more than one source is present, the response across any element in the circuit is the sum of response obtained from each source. Considered separately, in contrast, all other sources are replaced by their internal resistance. Example of the superposition theorem. For the network shown in the figure, to apply superposition theorem and find current I1. The Wheatstone bridge in the circuit shown in the figure is a balance when R2 is equal to 1200 ohm. If the galvanometer has resistance of 30 ohm, how much current will be directed by it when bridge is unbalanced by setting R2 is equal to 1204 ohm. Voltage source is 120 volt, R1 is equals to 900 ohm, R2 is equals to 1200 ohm, R3 is equals to 600 ohm, R4 is equals to 800 ohm. To find VOC, we are interested in the galvanometer and the circuit ends. Remove the galvanometer circuit to find K and we get the circuit shown in the figure. And we get I1 is equals to 120 by 900 plus 600. That is equals to 120 by 500 ampere. And I2 is equals to 120 by 1204 plus 800 is equals to 120 by 2004 ampere. Applying KVL clockwise along with the path, we get 1204 ohm B minus A into 900 ohm. We get 1204 I1 minus VT minus 900 I1 is equals to 0. And Vt is equals to 1204 I1 minus 900 I1. Substituting the I1 and I1 value in the Vt, 1204 into 120 by 2004 minus 900 into 120 by 1500. We get Vt is equals to 95.8 milli. Find RT. Deactivate all the independent sources and look into the terminals A and B to determine the Thevenin's resistance as shown in the figure. RT is equals to RAB is equals to 600 is parallel to 800, sorry, 900. 800 is parallel to 1204. We get 900 into 600 by 1500 plus 1204 into 800 by 2400 is equals to 840.64 ohm. Hence, the Thevenin's equivalent circuit consists of 95.8 megawatt source in the series with 840.64 ohm resistance. If we connect 30 ohm resistor to the equivalent network, we obtain the circuit in the figure. Ig is equals to 95.8 in 10 to the power of minus 3 divided by 840.64 plus 30 ohm. We get Ig is equals to 110.3 microampere. Let's we go to the next problem. For the network shown in the figure, to apply superposition theorem and find current I. Solution for this. Open the 5 ampere current source and retain the voltage source. The resulting network is the shown in the figure. The impedance as seen from the voltage source is impedance is equals to 4 minus J2 plus 8 plus J10 into minus J2 divided by 8 plus J2. We get impedance is equals to 6.01 at the angle of minus 45 degree ohm. Hence Ia is equals to J20 divided by Z is equals to, we get Ia is equals to 3.328 at the angle of 135 degree. Next, short the voltage source and retain the current source. The resulting network is as shown in the figure. Here I3 is equals to 5 ampere. Apply KVL to the mesh 1. Apply KVL to the mesh 1. We get the 8I1 plus I1 minus 5 into J10 plus I1 minus I2 into minus J2 is equals to 0. And apply for the KVL mesh 2. We get I2 minus I1 into minus J2 plus I2 minus 5 into minus J2 plus 4I2 is equals to 0. Simplifying the both equations, we get 8 plus J8 into I1 plus J2 I2 is equals to J50. J21 2I1 plus 4 minus J4 into I2 is equals to minus J10. And solving we get IB. IB is equals to I2. I2 is the getting by the matrix method. 8 plus J8, J50, J2 minus J10 divided by 8 plus J8, J2, J2 4 minus J4. We get I2 is equals to 2.897 at the angle of minus 23.96 degree ampere. Since IA and IB are flowing in opposite direction, hence we are doing minus. We get I is equals to IA minus IB is equals to 6.1121 at the angle of 114.78 degree ampere. Thank you.